Today we're going to learn how to spot proportional relationships in tables, equations, and real-life situations. By the end of this video, you'll be able to look at any example and say, yes, that's proportional, or nope, that one's not. Let's get started. A proportional relationship is when two quantities change at the same rate, so their ratio always stays the same. That means when one doubles, the other doubles too. If one triples, the other triples. The key idea: the ratio between the two quantities never changes. When you have a table, here's what you can do. Divide y by x for each row. If you get the same number every time, the relationship is proportional. That number is called the constant of proportionality, or K. Tables can look different. Sometimes they're vertical, sometimes horizontal, but the method is the same. Divide y by x and look for a constant result. If that ratio stays the same all the way down, you found a proportional relationship. Let's check out two examples. Table A. If we divide y by x, we get 15 every time, so table A is proportional. Now look at table B. The ratios here are 10, 12.5, and 15. They're not the same. That means table B is not proportional. So remember, if the ratio changes, it's not proportional. Now let's talk about equations. If an equation shows a proportional relationship, it looks like y equals kx. That means y changes by the same amount for every x. K is still your constant proportionality, the number that connects x and y. For example, y equals 5x. That's proportional, where k equals 5. Y equals 0.25x. That's proportional. K equals 0.25. But y equals 3x plus 2, that's not proportional. Why not? Because of that plus 2. Proportional relationships never have a starting amount or an extra. If x is 0, then y is 0. Here are some quick rules to remember. If an equation is proportional, it must look like y equals kx. Never have adding, subtracting, or exponents in a proportional equation. And you can divide, but not by the variable. For example, y equals x divided by 2 is proportional because it's the same as y equals 1/2 x. But y equals 2 over x, that's not proportional. You're dividing by a variable, which makes something non-proportional. Now let's look at real-world examples. A proportional situation has a constant or steady rate of change. That means there's no starting amount, nothing extra is added, it all starts at 0 and increases evenly. If you earn $12 for every hour you work, then 1 hour is $12, 2 hours is $24, 3 hours is $36. The ratio money divided by hours equals 12 each time. That's proportional. Apples cost $2 per pound. 1 pound is $2, 3 pounds is $6, 5 pounds is $10. Each time, cost divided by pounds equals 2. So that's proportional as well. A car travels at 60 miles per hour. 1 hour, 60 miles, 2 hours, 120 miles, 3 hours, 180 miles. The ratio miles divided by hours equals 60. Always the same. That's another proportional relationship. Now here's some examples that are not proportional. You pay $20 a month for your plan plus 10 cents per text. There's a starting cost, the $20, so it doesn't start at 0. The ratio isn't constant, so it's not proportional. It costs $3 to start plus $2 per mile. That starting fee means it doesn't start at 0, so again, not proportional. A runner starts fast, then slows down near the end. The speed keeps changing, so the ratio of distance to time isn't constant. That makes it non-proportional. Let's sum it up. A relationship is proportional if it has a constant rate or ratio, uses keywords like constant, steady, or same rate, and it starts at 0, nothing extra added on. A relationship is not proportional if the rate changes, there's a starting amount or flat fee, or something else is involved, like addition, subtraction, or an exponent. And that's it for identifying proportional relationships. Now you can look at a table, an equation, or a situation and decide if it's proportional or not. Remember, proportional means the ratio stays the same every time. Thanks for watching, and check out the channel for more practice or more topics on math.